Hi and welcome back to my channel. My name is Joshua from tagg. In today's video, we will start a new series on the topic data frames in R. So what exactly is a data frame? A data frame is a two-dimensional data structure in R that can be defined by virtue of its rows and column. So when we talk about the column, we are talking about each component. Each component constitutes the column, and the content we have underneath each of these components is what we have as our role. So this might look a bit theoretical, what I'm saying, but I decided to go online to have like a simple example of a table in Excel, and this is it over here. So when you look at it, we have like two columns, column A and column B. Column A provides information on topping, column B provides information on vote. So this column A is what I referred to as component A. In other way around, we can also see it as a variable. So this is component A or variable A or column A. This is component B, variable B or column B. So the content of the component, the content of the variable is what we now have as the rows. For instance, under the component A, which is topping, the first content we have is the cheese, and then for cheese, the vote, the corresponding content for component B is 6. So the entire row, which is numbered as 2, provides information on a certain individual or a certain observation. So this is a component, and then we can refer to the role as the content of the component or as an observation that is taken on a certain individual. So it is important we have this understanding. And so the entire data frame can be defined by virtue of its rows and columns. So we know this is having 2 columns, and we have how many rows for it? We have like 11 rows. So you can define it by virtue of the rows and the column. So this is the way a table looks like on Excel. So how do we now create a table in R? That is what data frame is all about. So let's go back to our R platform and let's create an example. So I decided to just start on the concept of creating a data frame in R and then support this particular video with some visuals. So let's take, for instance, for us to have a clear understanding of what is going on very well, the concept of a variable and the concept of an observation, defining them by virtue of rows and columns. So let's say we have like a student who is currently taking my R programming class or is taking a course on statistics with me. And so this is the guy, his name is John, for instance. And so John is a student in my class, and John is an individual. So on John, I am taking some certain measurable characteristics about John. I'm taking the age of John. I'm taking the score that John has in statistics. And again, in a test, I give John on R programming. So the test score is a variable. The age of John is also a variable. So the information that we now have under these variables are what we now have as the rows, and that is what we call an observation. Just as I can also take this on John, I can also take it on some other students that are also present taking a course in statistics with me. Let's take, for instance, they are 4 in number. So let's go to R and just have some little practice on how to create a data frame in R. So creating data frame in R. So to do this, there are several ways in which you can do it. The most important function we use is the data.frame function from the base package. So let's take, for instance, I'm just going to make it very easy. We have a variable called age, and the age is just for one person. The guy is 19 years old, and then I run this variable so it will be available on the global environment. And then it has scores. We have scores, score, and this guy has over 30, he has 25 over 30, and then I run this. So let's say I'm creating another variable again, and I say gender. So this is not a numeric variable, this is a categorical variable. So I say gender, and because it is a character, I need to introduce the concept of quotes. We've done this in the previous video. So I'll say gender male, and then I can program this. So right now we have 3 variables: age, score, and gender. And the information that we have, the contents of each of these variables, is what forms the rows, and variable forms are column. So let's create a data frame, and I'm going to call it like that. I'm not going to call it a data, because data is exclusively used to have access to some inbuilt data sets in R. So I said data, and this is the function we use in creating data frame in R. Just press data.frame. So this function creates data frame, tightly coupled collections of variables. Can you see it? Combination of variables. So when I say data frame, and then I'm now going to start imputing each of the variables: age, score, and then gender. So when I run this, when you check the global environment, you will see that there is a clear distinction now. We now have something different from values. We have what we call data. So most times when you have data in R, it is a combination of values. Values are seen as variables. So it is important we have this understanding. So data again is a combination of values. Values are known as variables. These variables can also be referred to as components, as seen in some other textbooks. So when you click on this particular thing, let's see what happens. This is it. So the age is a variable, the score is a variable, this gender that we have in the third column is also a variable, and then the row gives information like the content of each of the components, each of the variables forms the row. And so we have just taken the content on a certain individual whose name is John. So let me close this and go back to what we have. So I can easily check the dimension of this particular stuff and say dimension DAT, and you will see the dimension is of 1 by 3. That is 1 row and 3 columns. So let's take, for instance, we now want to take the information on the age, the score, and gender of not just John alone, but these 4 students who just joined my class on statistics without reprogramming. So I would go back to each of those variables and add the information of the remaining 4 people. So let's say this is for John 19. I'm adding the information of the remaining 4 people. Let's say the next person, the age is 21, and we have someone who is young, 15 years old, and the third person that just joined is 18, and we have someone who is extremely very old, is 29 years old. 29. So I have told us if I run it this way, I'm just going to find myself in error, because we are combining more than one observation and we are storing it in a variable. We introduce the concept of vector, and it's very simple. You put C, then you you use the values as the only argument in the vector function. So if you run this, when you check the global environment, the value for the variable age has been updated, not just as 1, which is 19, but now the remaining 4 people, their information has been added to age. So let's go to score. This person has a very brilliant score, 30-30. This guy has 28, and this one has 26, and this one has 17. So invariably they are all brilliant students. So again, we combine them together using the vector function. So let's talk about the next one. When I run this, it gets updated on the global environment. So let's go to the gender. So I know we're also going to combine it. So the first person is male. Let's say the next person is female. You quote it. The next person is female again. The next person is male. And the last person is a female. So I close the bracket and I run this. So it gets updated on the global environment. So if I run again the code I have in line 7, you are going to see that the whole data frame is going to get updated and have a new look. So when I run this, you'll see on the global environment, we now have the data frame to be 5 observations of 3 variables. So this observation means 5 rows. The variable means column. So if you have to define this now in terms of rows and column, when you run the dimension, you will see it's going to be 5 by 3. So if I run this, it tells me this is 5 by 3. So invariably, what this is trying to tell us is that we have 5 observations, that is 5 information on some 5 people, and the information we took on those 5 people are just 3 in number, and that's what constitutes the variable. So in this way, we can create a table, our Excel table that we've seen. We can create it in our using the data.frame function. So you can check the structure, because we have the belief that each of these things that we have in the data, which is a table, is a combination of different variables, these 3 variables. So it is possible you check, for instance, you might want to have like access to one of them, of which I will still talk more on this extensively in subsequent videos. So I can say that, and then I will use the $sign so you could see. So it gives you access to each of those variables that you initially combined together and store them in a variable called DAT that forms our table. So if, for instance, I'm interested in the age alone, the vector value in age, I can run it and then I have age alone. So you can check the class to be sure that this is a data frame. You can check the class of that and it tells you that, come on, this is of the type data frame. You can also check the structure. So you see the structure of that, and when you use this function structure, what you are having in mind is to have like a quick insight to the data. So the structure is going to tell you the classes of each of the variables. It's going to tell you the number of observations we have, the total length, etc. So if you run this, you could see it tells you 5 observations of 3 variables constitute the entire data frame that we store in a variable called DAT. And then the first, you could see the $sign. So most times, whatever result you see in R has a meaning. This $sign, for someone who doesn't know anything about R, would be wondering, oh, it's just there for just their sake. But it is not just there for fun. It is trying to tell you that in the case where you're interested in just having age alone, all you need to do is call the variable with respect to $sign, and then you put the age. You have the variable age alone. The same thing with score and gender. So now it tells you that the class of this is numeric, the class of this is numeric, and the class of this gender is character. So there is something that is going on underground. So let's take, for instance, I am going back again to run this whole thing. And then I just want to talk about the concept of that class where we have the gender to be automatically referred to as character. So if I come to this place and I add comma and I add an additional argument and I say string as factor and I say true, and then if I run this and I go back again to check the class, I still have it as data frame, and I check the structure, you would see that the gender is no longer referred to as character. The gender is now referred to as factor with 2 levels, and that is the best way it should be, because this is not just an ordinary categorical variable. It is a categorical variable that can be ordered. I mean, that has levels, that has some unique levels. They can be ordered, but they have some unique levels. They are nominal, male and female, male and female. So for such a variable in R, it is best we classify them as factor, and we will still see this in some videos I still have to share with us. So this is how you can create a data frame in R. I'm just going to say something before I close this video. If you have been following this channel very well, you would see that the last thing I did was a series on matrix. And if you check carefully in terms of the physical appearance of a matrix, the way a matrix will appear in R programming and the way a data frame will appear, they almost look alike in terms of structure, but they are quite different. For instance, let's have an example. I'm going to create a matrix, and I would say math. Okay, let's store it in math, and then I say this is matrix. And let's still use the simple example we've been using all this while. That is the data we are using to form a matrix, and it's going to be of the dimension 3 by 3. Yeah, and then I can run this. So we have a math. I can show you the math. This is the math. It looks like a table, but this is a matrix. And then we're going to see the difference between a matrix and a data frame. But before we do that, there is something we did in the last one. We used these column names, the function, and then we say math, and then we provided some names for each of the columns. So let's say this, I just want to have something that will look like what we have created. I said age, and I say score, and then I put this as TST, for instance, and I run it. So if I check math again, you will see that math has been updated. It looks more like a data frame, more like a table, but yet the class still reveals to us that the class of math is not a data frame, it is a matrix. So there is a concept we call the concept of coercion. So this concept of coercion talks about how you can change the class of an object from a certain level to another type. So for instance, we all know that math is of the type matrix or an array. So how do I coerce it? How do I change it from this type to a data frame? Because it's looking more like a data frame, but it's quite different. So how do I do that? Now I can say math, and then I'm going to say this math now is the new one I'm creating. So what I'm doing now is I am overwriting. I'm not changing the name from math. If you check the global environment, you would see that we have this icon that looks like a play button. Whenever you see that in arrow programming, that tells you that that's a table created with a data frame, or that is of the type data frame. For the case of math, it doesn't have that, and it tells you, you could see, it tells you that that's a matrix. So what am I trying to do here is I'm still trying to like retain the name that we give the variable math, but I'm changing the class from a matrix to that of a data frame. So I will say as .data.frame. This is the way you change. So I am changing it, the old math, which is of the class matrix. Now I am changing it to a data frame. So I'm using this function as.data.frame. And so if I run this, if you check math on the global environment, it now have that icon that looks like a play button. And if you check the class new, you would see that math has changed to a data frame. So it is possible you coerce, it is possible you change the class of an object from what it used to be, and then you change it to a new class you want it to be. This concept of coercion is very important in data analysis, because when you have a data set and you are to perform a certain analysis on this data set, it will be wrong of you to just jump into the analysis without checking the structure to be sure that each of the variables we have in the data set conforms with the best type they should be for such an analysis. So I would, before I stop, let's stop at this point. And okay, before we go, something just came to my mind. So look at this. We have learned the concept of creating a data frame using an existing variable. That is, we first created a variable. It is also possible you create everything once. So this is what I mean. You can say book like this, book, and you say book is a data frame, data.frame, and so you can have it name. You can say I don't want num like this, and then you say this. I don't want us to waste time. I'm just creating two, and I'm saying mn. Let's say chemical element, and this is hydrogen. Helium. And so we have that, and then this is abundance. I just call it ABD, like abundance, and then this is 25. How the percentage of this particular thing in a particular environment, and this is 32. So if I run this, you will see we have book being created as a value that has two observations of two variables. So when you click it, you have it here. You have it there. Very easy. So when you look at what is going on in this particular place, you would see that we have this name, ABD, etc. So it's also possible you could see it again in some other textbooks or in some other resources again on our program. You could see them do stuff like this. And then when you run the entire thing, you can highlight the whole thing and run it. When you check again the book, you would see they still give us the same thing. And so, like I told us, BOK, you can use this $sign to access the information that we have for that particular one. So at this point, I would want to say a big thank you for your time. Thank you for choosing to learn art with me, and thank you for subscribing to the channel and sharing with your colleagues too. We just in just a few months, I could see that we now have more than 400 subscribers, which is a very good number, an encouraging number. And I want to promise that we are going to learn more. We're going to learn more about our programming in this channel. So once again, thank you for your time. May God bless you.